Okay, today we are going to solve one algebra problem in Imo2023, which is placed in problem 4. Actually, this is a very easy question, so let's do it. Looking at the problem, we know that x1 to x2023 are all different real numbers, and while an is an integer for every n equals to 1 to until 2023, so we have to prove that a2023 is larger than or equals to 34. So you might think that 2023 and 34, they might have something in common, because this equals to 1 plus 2 times 1011, and then equals to 1 plus 3 times 1011. So we might think that 2023, how can it be connected with 1011? So my answer is that if we use this to get the largest integer less than or equals to 2023 over 2, and that equals to 1011. So while here exists one number 2, so there must have something to do with the number 2. So we might think of these two integers. They are an plus 2 and an. So if we can make sure that there is this kind of thing, so it holds, right? And since an plus 2 and an are all integers, so we can also say that it is equivalent to an plus 2 is larger than an plus 2. Is that right? So that's what we want to prove. And an plus 2 is square equals to, oh no, not the root, x1 plus x2 plus 2, xn plus xn plus 1 plus xn plus 2 times 1 over x1 plus 2 x1 over xn plus xn 1. So that's it. And if we denote that letter A, capital, equals to x1 plus 2 xn. Letter B, capital, equals to 1 over x1 plus 2 1 over xn. You can know that an plus 2 squared equals to a plus xn plus 1 plus xn plus 2 times b plus 1 over xn plus 1 plus 1 over xn plus 2. Right. So according to Cauchy's inequality, Cauchy's inequality, we can have that this thing is larger, or no, it is only larger. Let me explain it to you. Then after that, it is larger than AB plus. Here I will write it. I will have one more page, which is inequality. That is ax plus by squared. It is less than or equal to a squared plus b squared times x squared plus y squared. That's why is it? So we can make a subtraction like a squared plus b squared times x squared plus y squared, and then minus a times x minus plus by and square. After calculating, we must find that it equals to ay plus bx minus bx square. And of course, it is non-negative, and the equation holds when ay equals to bx, right? So here is the same. Equation holds only when a times x. The purple thing, their sum, not sum, b times xn plus 1 plus n xn plus 2 equals to a times these things. So that requires that x1 equals x2 equals x3 until xn plus 2. So that is against the problem, because they are pairwise different positive real numbers. So here we cannot get the equation. So this thing equals to an, because an squared equals to ab. According to the definition, an equals to ab rule. So, and here we can just simplify the thing under the rule. So it equals to 2 plus xn plus 1 over xn plus 2 plus xn plus 2 plus xn plus 1. It is larger than an plus 2 plus 2 squared equals to an plus 2 squared. So here, why can't we get the equation? Because we have one, like here, x over y plus y over x. It is larger than 2 times xy times yx equals to 2, right? That only holds, equation only holds when x equals y. So it is the same thing. So xn plus 1 that is different from xn plus 2. So this can hold. So here we get an plus 2 is larger than an plus 2. So that's what we want to get. It's equivalent to an plus 2. So let me explain the last one to you. Why we do this? Because A2023 is larger than A2021 plus 3, right? So once here the number minus 2, we will get 3 times 1. So how many 3's can we get? That is this one equals to 1011. So that's the end of the proof. Thank you for watching.